Hi there, this is a video on the Unit 4B Circle Theorems and Constructions. So we're going to begin the video by just saying this is the version without the asterisk on there. So this is version A or version 1. So I will do another separate video for version 2, and then I will do one other separate video that includes both versions 1 and 2 of the constructed response. So, number 1, you're just doing vocabulary and reading from the picture here, and it says, which of the following is a secant? Well, right off the bat, I know that secants are lines, and lines are indicated by arrows over it. So automatically, that's a line segment, that's a line segment. So then at this point, I have to find the difference between GI, which ends up being a tangent, because it only intercepts the circle at one point, or EF, where it intersects the circle at 2 points. And so that actually EF is going to be my secant, line EF. Which of the following is a tangent? Well, we just covered that. Number 1, it's going to be a line. It's not a line segment, so automatically I can eliminate C and D. And then from number 1, I know EF is a secant and GI is a tangent. It only touches the circle at 1 point. 1 point. Okay, and then looking at 3, it says in the diagram above, segment AB is best described as well, number 1, we're talking about a segment, not a line. So it's either going to be a chord, radius, or diameter. And it says AB. And a line segment AB, its endpoints are on the circle, and the definition of a chord is a line segment that's endpoints are on the circle. So in this case, the best description of segment AB is a chord. Number 4, you can't answer this problem without writing or drawing a picture and knowing basically the definition of a central angle. And a central angle has the center at has the vertex at the center, and from our formulas that we learned, the measure of the angle is equal to the measure of the arc. So we know that this central angle measures 97 degrees, so if this angle is 97 degrees, the arc that it intercepts is 97 degrees, and that is the minor arc. So it asks you to find what the major arc is, and so to find the major arc, I take 360 minus 97, and that's going to end up being 263. So my major arc here is 263 degrees. Number 5, I have what is the angle of WTV. So right here, I'm going to just mark WTV. And I know that my vertex is on the circle, and so the measure of the angle is equal to the arc divided by 2. And so I'm solving for the measure of the angle, and the arc that it intercepts is 90. So the measure of the angle is equal to 45 degrees. Number 6, it says, what is the measure of Z, Y, X? Well, automatically I can see that the vertex is on the circle. So once I find the intercepted arc, I can say that the measure of the angle is equal to the arc that is intercepted by that angle divided by 2. But if you notice, we're given the arc that is not intercepted by the angle. So to find ZY, the minor arc ZY, I have to take 360 minus 194. And when I do that, it is going to be 166. Okay, so the measure of the arc that angle intercepts is 166. So the measure of the angle is equal to 166 divided by 2, which is 83 degrees. Moving on along to number 7. Excuse me. Number 7, it said DG and HE are diameters, and then it says which of the arcs measures 134 degrees. So I'm just going to go ahead and I'm going to figure out what the measures of some of these arcs and angles are. Well, I know they're all central angles, so the measure of the angle is equal to the measure of the arc. So this is 46 degrees. This is a right triangle. I mean, not a right triangle, a right angle. So I know to find this, I would have to say 99 minus 46. So that's going to be 44 degrees. I know that this is 90 again because it's a 90-degree angle. I can either find this two different ways, knowing that it is a vertical angle. I know that it's 44 degrees, or I can take 190 plus 46 is 136 and subtract it from 180. And then at this point, once I have all of this, I can figure out that added together, these are 64. And so I do believe that that's 180 minus 64 is 160 degrees. So at this point, I can find the measure of the arcs. So at this point, FJ, and only has two, so it's a minor arc, FJ, is going to equal 46 plus 44 plus 20. DF, and I know it's going this way because it's a minor arc. It's represented by two variables, 44 plus 90. And EG, EG is 90 plus 46. 90 plus 46. And then DH is 116 plus 20. And so I just add all of these up. Degrees. And this one's 134 degrees, and here that's going to be, I do believe, 110 degrees. So my answer is going to be B, DF, or DF. Here it says what is the measure of the arc, measure of the minor arc, and so I'm solving for X here. And I know that this is a vertex outside the circle. So the measure of the angle is equal to the arc differences divided by 2. So I need to know what this arc over here is. And I don't know what it is, but I surely can put it in terms of x. So that one would be 360 minus x. And so then I'm plugging it in. Measure of the angle is 65 degrees. 360 minus x divided by 2. Multiply both sides by 2. Those cancel out. 130 is equal to 360 minus 2x. When I combine negative x and negative x, subtract 360. Negative 230 is equal to 2x divided by 2. Negative 2, that would be negative 2. And it's 115 is equal to x. So that would be the minor arc. Number 9. I want to solve for x, and x has to do with this angle that is an inscribed angle with the vertex on the circle. So the measure of the angle is equal to the arc divided by 2. So here I know that this is a diameter, and so this arc is 180. So the measure of the angle is equal to 180 divided by 2, which is 90 degrees. And then I set 90 degrees equal to 2x plus 5, and then use the mad algebra skills and solve for x divided by 2, and so x is equal to 42.5. Number 10. This one is you have a few steps involved in this, and it says you want to find the measure of JBM. So looking at my figure, I don't have any arcs that are going to help me. I can figure them out. Or I can solve for this angle right here and then know that those two are supplementary because they make a line. So if I do it that way, I can solve for this angle right here, and that is the measure of the angle. The formula is the sum of the two arcs divided by 2, and that's because the vertex is inside the circle. So basically I'm kind of ignoring the fact that I want JBM, angle JBM. So I have measure of the angle is equal to 130 plus 70 divided by 2, 200 divided by 2, so that's 100. So this angle right here is 100 degrees. And to find this one, I take 180 minus 100 is equal to 80 degrees. I also could have found, well, that is how I could have found this by knowing that that's 200, that these two added together have to be 160, and divided it by 2, but you can figure it out from the formula this way. It says, what is the measure of ACB? So the first thing I know is I have the measure of an inscribed angle. It's going to be arc divided by 2. So 50 is equal to the arc divided by 2. So 100 degrees is equal to the arc. And at that point, then I know that these two are central angles, and the measure of the angle is equal to the measure of the arc. So the measure of the angle is going to equal 100 degrees. Number 12, it says you're constructing an inscribed circle for JKL, triangle JKL. Inscribed is going to be inside, and we discussed that inside is going to be, you're going to need to construct a angle bisector. And so this is just knowing how to construct an inscribed circle to be able to answer this question. Number 13. This we're dealing with segment lengths, and I know that the vertex is inside and it's 2 chords, and so it's part times part is equal to part times part. And so I multiply 9 times 8, and it's going to equal 2x times x. So 72 is equal to 2x squared. X times x is x squared. Divide both sides by 2. And so it's 36, because x times x is x squared. Divide both sides by 2. I'm left with x squared is equal to 36, and so x is equal to 6. Number 14, we have tangent squared is equal to out times the whole, because I have a tangent and a secant. So tangent squared is 12 squared is equal to the outside times the whole, 9 plus x, because the whole is 9 plus x. So I have 144 is equal to, I distribute 81 plus 9x minus 81. And that is going to be 63 is equal to 9x divided by 9, and x is equal to 7. And then the last one of the multiple choice is number 15. And it has to deal with the construction of 2 tangent lines. And so I know during the construction of 2 tangent lines, I'm creating 2 tangents from the same point, so they're going to be congruent to each other. I have 2 radii. They are congruent to each other because they're both the radius of the circle, C. And then I know through my perpendicular bisector that I have actually bisected line segment CE to create 2 congruent line segments CM and ME. So at this point, I've kind of labeled what I have, and you can kind of go through and eliminate some stuff. So the first one says DE is congruent to CE. Well, I do not know that DE is congruent to CE. So right off the bat, I know that that one's not always true. I do know that CD is parallel to DE because by definition, the radius and the tangent form a right angle. I know that MC is congruent to ME or EM because you're bisecting that segment CE. And then I know that DC and CF are congruent because they're radius or they're radii. So the answer to 15 is A. So do not forget, if you're going to do point recovery or retest, that you have to fill out your test correction form. So please make sure that you are filling that out before coming for your test corrections.